Alright, example 5. An object moving along a curve in the xy plane is at position x of t, comma y of t at time t. So there's no set values of t. T is greater than or equal to 0 with dx dt equals 2t e to the t minus 1 and dy dt equals t cosine of t squared minus 1. At time t equals 1, the object is at position 3, 4. For part A, it says, find the equation of the line tangent to the curve at t equals 1. So for tangent lines, really all you have to do is find the point and find the slope. That's what you need for a tangent line, right? Because we're going to use this equation. So we need this, we need this, and we need this. And so it says find the tangent line at t equals 1. So that's important. The point, well, it's actually given to us at time t equals 1, the object is at position 3, 4. So the point is 3, 4. And then the slope, well, remember that for parametric equations, the formula for slope is dy dt over dx dt. And yeah, this is another formula that you have to memorize most likely. So dy dt that's given to us, it's this, and over dx dt, it's also given to us. And we have to find this evaluated at t equals 1. So when you plug in 1 into t, you're going to get 1 times, I'm plugging it into here, 1 times cosine of 1 minus 1 is 0. Over 2 times 1, which is just 2, times e. When you plug in 1 and a t here, you get e to the 1 minus 1, which is e to the 0. E to the 0 is just 1. So cosine of 0 is 1, and 2 e to the 0, that's just 2. So we got our point and we got our slope. Nice. So now we just gotta generate our tangent line equation. So our tangent line equation is y minus y1, which is 4, equals m, which we just found, is 1/2 times x minus x1, which is 3. So that's our tangent line equation. If you want, you can simplify it further. I'll just do that. 1/2 x minus 3/2 plus 4. So either one of these would work. Okay, so 5b, it says find the instantaneous acceleration of the object at time t equals 1. So remember that the acceleration is the second derivative of the position. And we have our x part and our y part. And we're going to find it time t equals 1. So we're given the derivative of x and derivative of y. So to find the second derivative, we have to take the derivative of the derivative. So you have to take derivative of dx dt. So let's do that. So I'm gonna actually pull out the 2 here to make it easier and use the product rule. So it's the first times the derivative of the second, and derivative of e to the t minus 1 is the same thing, plus the second times the derivative of the first. So derivative of t is 1. So I'm gonna evaluate that at t equals 1. So when you plug it in here, you get 1 times e to the 0, which is just 1 times 1. So 1 plus, and when you plug in 1 here, you get e to the 0, which is just 1. 1 times 1 is 1. You get 2 times 2 is 4. So we just found this, right? And now we gotta find this part. Let's do that here. Y double prime of t is, so we have to take the derivative of this. So it's gonna be product rule again. So the first times the derivative of the second, well, this is gonna be a chain rule. So once you do that, then you have to take the derivative of the inside, do t. So first times derivative of the second plus the second times the derivative of the first, which is just 1. Now we have to evaluate it when t equals 1. So when you plug 1 in here, you get 1 times negative sign of 1 minus 1. Well, that's sine of 0, right? And the sine of 0 is just 0. So whatever the other things are doesn't really matter, because it's just going to end up being 0. 0 plus cosine of 1 minus 1. Cosine of 0 is 1. So yay, we found both these. So the instantaneous acceleration at t equals 1 is that. So cool, we did it.